My co-host today is Dmitry Silevsky, who is our top man in Kafka. Then we have Roman Zhuk, who did some of the cool POCs for us, but he's too shy to speak out. So, he kind of gradually will learn how to participate in such an events and later can share, huge story of complex implementations he done or cool implementation he done. And also Alex Kartashev is supporting us. For some reason, he still didn't go for parental leave. And, we have like strong backup in this session as well if something goes wrong, because we do this crazy stuff as like live demos, and live demos always go wrong or often go wrong. All right, so I will start sharing the screen so that you see some more. And the topic for today is data streaming with Kafka. And taking one step back, last week we had this overview webinar when we explained that during Siebel Virtual Summit this September, Oracle announced two cool things. In our opinion, one is cloud native architecture, basically ability of running Siebel within Kubernetes cluster surrounded by different backing services, which provide observability, service mesh, deployments, all cool stuff. So it's like people are building now microservice applications and run them in cloud native, and now Siebel will do the same as these kind of young chaps. I don't know if it's correct or not. So another cool thing was this real-time, or properly called event driven framework for Siebel. And effectively, we can call it native Siebel Kafka integration. So Siebel can publish and subscribe stuff from Kafka topics. And then the third initiative, our favorite topic, that's where we shine, at least at this moment, but maybe we will be kind of good players also in cloud native enterprise and Kafka, is Siebel UX. And there was a webinar on Wednesday. So cloud native was Monday, Wednesday was Siebel, and then today, Friday, we have Kafka as a topic. All right, if you want to listen to Oracle speech, both about cloud native and event-driven frameworks, these are two webinars for you to watch from Oracle. So if you kind of go click on this link, bit.ly Siebel Cloud Native, you will be taken to a page on the Oracle site. And here are two webinars you want to listen. One relation with Kafka and Siebel Cloud Native Architecture is such that Siebel is rewiring how its different components are talking to each other and communicate. They will be getting rid of Siebel Request Broker, which ensures this inter-component request handling. And this component is going to be replaced by Kafka. So you want it or not, but if you deploy Siebel in cloud native environment, you will have Kafka in your cluster. So let's think, how we can make a good use of it. Kafka is not being used just for Siebel purposes only. So they've done this native integration between Siebel and Kafka so that declaratively through some runtime events and another type of technique that they're doing, you can both publish directly messages to Kafka and read from those, but also you can do the same stuff from the scripts. So like your server script on the business component level, on the business service, a lot of flexibility that we usually expect from Siebel now will be kind of also applied to talking to Kafka. I did another direct link to Oracle video. So if you go bit.ly Siebel Kafka, you will be taken to Oracle video site. And there, if you watch 10 minutes from 35th to 45th minute, then you will see both Oracle explaining how that stuff works and also how do you actually work with Kafka through runtime events and through the scripting. So they have kind of demo as well there. It will give you a good understanding of what's going on. An overview for today. So usually when we speak about Kafka, we kind of highlight its characteristics, because even with Alex Kartashev, who is on the call, we have this discussion, is Kafka a message queue or not? And what the heck is the difference? So, but basically, you can look at the Kafka, yes, as a message queue on one hand, and good things about it that it provides you very low latency so that you can move data from one system to another if you use it as a message queue. It scales really well because initially Kafka was developed within LinkedIn, where they have struggled to how we push all the activities which customers are doing in their business social network to other users. And this is where the Kafka was born and then later on donated to Apache. So it's an open source project. But there is also a company called Confluent, which is providing Kafka in the commercial way. And it has some also free components, but also you can get sort of premium support for that and some pretty awesome capabilities. Some features do end up in the open source, the free version of Kafka, some not, but let's see how it will evolve. Okay, but this is more mainly about the message queue. I think what is also making Kafka different is that they look at these different messages or events going through the topics or queues as a log of events. And basically they say, hey, you can have any time to live for these events as you want to. So if you want to you can store these messages forever. Now they are doing some improvements so that it's not that expensive to store the data in Kafka. And now they are also sometimes talking, is really Kafka a database or not? Because since we have all this data going through our topics and we can persist them, maybe we can use them as well in some other way. And one way how to use it is actually what they call like stream processing. So basically, how can we process in the real time all the events which are going through Kafka topics and make some actions or analysis on top of that. And this is, I think, kind of another distinctive feature of Kafka, so that you can do actually some analytics, apply some machine learning to detect some anomalies, some opportunities, threats, do some KPI calculations, all based on this stream of events which were going on. And today we're going to speak a bit more about this as well. Siebel related aspects to that. So we expect Kafka next year, so 2021. And customers would need to update to the latest Siebel version. As I mentioned, that you will be able to publish and subscribe your events or messages, depends how you look at Kafka, both declaratively, for example, through runtime events, but also using scripting, so like Siebel way. If you kind of adopt cloud native architecture, you will have already Kafka deployed in your Kubernetes cluster. Siebel is using Kafka for internal purposes to communicate between different components, but then you can also use the same instance to do some of the data exchanges. And for now, because there is no this native connectivity with Kafka that Siebel provides, and we have to wait for that, now you can publish messages to Kafka either through REST services and custom connectors, but another good option is to use change data capture on the database layer. And this is like what we're going to tell a bit more today, as we have this particular use case implemented at one of the customers of ours. To consume the data, usually we would have custom connector, like sync connector developed, which would listen to certain Kafka topic and then do some stuff and call Siebel REST service to put the data into Siebel. And this is like another use case we implement at different customers of Siebel. For the use cases we discussed last time, audit of whatever customer is doing or users are doing within the system and other type of events, maybe what customers are doing somewhere. Particularly, we will look into query improvements, how we can make read requests from Siebel faster and from external systems as well. Google-like search, we will touch on that as well. And some challenges we have to find to overcome. And I think kind of exciting part is going to be more about this streaming API, basically stream processing, what we're going to do. But first, maybe, Dmitry, you can unmute yourself and I will walk through the slides and you will do basic introduction to what Kafka is all about and what are different pieces it consists of. Please go ahead, Dmitry.
Yes, thank you. So let's start with the first picture. On a highly conceptual level, every user action, every change that was ever done to the database basically can be named as a continuous endless sequence of events. So anything that is happening to the system, any user activity, it can be represented as event. And Kafka builds on this idea. And Kafka topics are the way Kafka stores these events in its own persisted way. We can treat these topics as a queue, but the main difference from the queue is that any consumer that is allowed to read from the topic may read from any point in the topic, maybe from the beginning, from the middle, from the end, wherever it needs to read from based on business requirements. And this topic, in a way, is shared between multiple consumers. And in this way, it does not consume additional storage space for each of the consumer, but at the same time allows to track and process these events from any point of time in the topic. Around Kafka, we may say that we have different event producers. As I mentioned, as event producer, this can be any kind of system, any kind of process, user clicked events, it can be EOT stuff, collecting different monitorings, and it can be even enterprise line of business systems where any change to the database can be converted to the event that's later put into topics. On the right side, we might have different consuming system, and these consumers can be out of any domain, like even data lakes, search engines, where we upload data for further indexing and faster searches, even mobile apps, or better to say backend storages for mobile apps, or any other applications with their own storages can receive messages from Kafka topics and build their internal business logic based on the events that are provided by Kafka. To help connect these different producers and consumers, obviously these systems might come from different times. One can be pretty modern applications, other might still be using something like XML as a native format. To overcome these challenges with communication, the concept of connectors exists that helps producer system and consuming system to communicate with Kafka. There is a pretty good collection of out-of-the-box connectors provided by Confluent, but at the same time, if they do not satisfy your requirements, additional connector components can be built pretty easily. They can be built pretty easily. So the last but not least feature that we should talk about is stream processing. That on a simplistic term, this is a process that can read some events from one topic, do some internal processing of the stream, and write it to the output. But the interesting part is that instead of looking at each event individually, when working with stream, we may overlook over multiple events over some period of time and create some business logic, create some scenarios to react on what is happening over time with data, with these events. And from that, the most simple scenarios that come into play here is like a fault detection or some fraud detection or detecting some malfunctions or inconsistent behavior that should not be there. Like, for example, some spikes in metrics received from devices or some unusual behavior.
Okay, I take it back. Maybe we'll speak a bit more about the different use cases. Some will have demo, some are POC we built, some real life experience of how we used Kafka before. The first one, it's I think pretty straightforward scenario, is a bit boring as well. That previously at Tele2 there was this requirement to capture all of the events when Siebel users are accessing customer data, and we needed to keep a log of it. So our guys built some of scripting within OpenUI, which would send the message to Kafka queue or topic, and then through that topic, it would end up into Elasticsearch solution. And then in Elasticsearch, with the help of Kibana, we had different charts and search functionality to figure out which users accessed what data and if it's fine or not. But it was more like audit, so there is no business logic was developed on top of it. It just, we store the facts which happened, and that's it. Actually, there is a blog post on our site, so you can go and look for that and check it, about user audit trail. We also have some JavaScripts we could share with you. So, and if you are interested in this scenario, come and speak to us. We'll happily share this stuff that we have. You heard Kafka, you heard Elasticsearch, and you heard Kibana. And as you know, Elasticsearch and Kibana is also going to be part of these different observability services, which will come with the Siebel Cloud Native Architecture. So basically, these components you would already have with the Siebel Cloud Native as well. So second use case, and again, it is to some extent relates to what we do as a company trying to focus on user experience, is how can we speed up performance. Of course, there are companies like this huge airline company in the States which solve its Siebel performance problem just by buying Oracle Exadata machine. I think that's a very smart way of improving Siebel performance, but not everyone can do that for Siebel instances. So we need to figure some other way, because in many cases, when it comes to user, good performance of the application means good user experience. If you start talking about e-commerce solution, there are a lot of studies saying that the faster the application is, the faster user is able to complete its use case, more stuff they order and buy. Okay, so performance is a key. Analytically, here I will try to explain stuff. So the way how we look at it is that we try to use this CQRS, or command and query responsibility segregation pattern. So basically the idea is that we have a consumer of the data, and when this consumer wants to update or create or delete some of the records, if the consumer wants to issue commands, we go one way, and through some kind of command handler, we update the main storage. And then there is a projection process happening on the background. Either we do it in the straightforward way, just moving the data out of this main storage, or we do some transformation in between. But basically, we end up with the read storage. And basically, the same consumer which wants to read data only goes another way. So it issues a query, there is query handler, and then this query handler works against the read storage. And typically with this pattern, we want to do two things. So first thing is to improve read queries performance, which is important, but also since we take away the load from the read queries, we make sure that the main storage or main application is working faster as well. This is actual case, and I'm talking about our client whom we also presented Siebel UX work back in February, one global manufacturing company based in Finland. For this company, we are building mobile applications for technicians and salespeople. Effectively, it's running or accessing the internal network through Azure. This customer is heavy Azure user. There is Azure API gateway for all the security and stuff. And from there on, we go to on-prem or internal network where we would interact with Siebel through REST APIs. And one of the problems with this approach was that if we want to query Siebel data by ID, or if we make the call which return flat data sets, it worked very well. But in many use cases, the mobile users would need to get thousands of records, sometimes with complex hierarchical structure, like asset structure with the service request and stuff like that. And these queries would be kind of somewhat slow. And plus, we need to take into account that there is latency added because of the Azure and on-premise connection. So what we have done to speed up performance, we exactly implemented this CQRS pattern for commands like updating Siebel data, inserting the new ones. I don't think they do delete, so we still use Siebel REST services so that we don't need to re-implement all the business logic. And if for some reason the command issued by the mobile app violates Siebel logic, it kind of fires back immediately. So we keep data in order. And that works fine. But then for all the queries, we use another data source. So in our case, it is Cosmos DB. So no SQL service from Microsoft Azure. We have some REST API on top of it without going into details how we do that. But then for this projection activity, we use Kafka. And again, maybe it's a bit simplified picture. We can go into the details if you want to, how it's done. For example, the challenge here was that here, from the Siebel database, we get changes on particular record, let's say, as contact table. But then from the Cosmos DB point of view, this could be a contact person of the customer, and this line exists in the multiple documents in the Cosmos DB. So, some of the document collections could be related to accounts and all the contacts. Some could be data collection where all the service requests exist, which particular technician should serve, and this contact is also a contact person whom technician needs to call when they get on the customer side. How to turn this single record update in Siebel, make business sense out of it, like what kind of data it is and what kind of document 1 or 10 or 100 documents need to be updated in Cosmos DB, it was a challenge here. But effectively, on the high level, it is this CQRS pattern so that we push the data out of Siebel and move it into Cosmos DB, and we use Kafka because we like the performance and how fast it is. Some of the performance gains, we kind of did some measures as well. So effectively, if we do the record count in the database, business component, and Cosmos DB, so kind of two main entities we work is accounts. So in database, we have 600,000 records. In the business components, it's slightly less, 550,000. In the Cosmos DB, because we don't need to push all of the data, it's 500,000. With assets, it's all that from 85 million the database, because we kind of at this moment were getting only root assets like headers, we would have 2.5 million, and at the Cosmos DB, we would need to push 1 million of the data. And then if we look at the improvement, then if we do the read queries on the flat objects by ID, we're just getting maybe 20%, 70% improvement. If we start querying hierarchical objects and we kind of get rid of several calls to Siebel, because in Cosmos DB we have these pre-cooked documents already, which can be fetched in one call, we get 2 times or 3 times or 4 times performance, which also depends on the amount of data we want to push through. If this amount of data is growing, the larger response size, we get better performance improvements we experience. So at maximum, we kind of calculated that it could be as high as 13 times faster performance. There is complexity added to overall architecture, but the gains for the users and from the user experience point of view, were justifying adding this complexity. If we look pragmatically at where we could be applying it in the Siebel domain, so first would be similar to this scenario, we could be pushing Siebel data into digital applications. By digital, I mean all the end customer facing applications, which need to have very fast response times. And typically, they get customer data from Siebel in the real time. Instead of the real time, let's push it to whatever data source this digital application has. Another scenario is different mobile applications like we had with this customer. The same logic works in another direction. Like we have another customer who wanted to implement a nice customer 360-degree view so that they get like all the data in one page about this customer. And the way how they implemented it, they built 3 or 4 virtual business components, which reads the data from not so fast backend systems or source systems. And the problem was that whenever customer or the user would go to the summary page, it would have to wait for a second or two, because getting the data from the different data sources in sequence, merging it with Siebel data, it was just taking too much of the time. And on one hand, implementing VBC is sort of standard way, and it's not that difficult to do. But again, from the performance gain and kind of decoupling of the application, because the source system can be down, the source system can be like really slow, and it all affects us. So we can replace it by streaming the data from the source system to whatever needs to consume it. Putting up these routines in Kafka, it's not the rocket science, and it's not really complicated things to do. As of now, we, again, still do not have this native capability from Siebel, which is coming with the Event Driven Frameworks. So we can do now, so as a source connector, typically we would suggest to use change data capture solution working on the database level. So if you are a Microsoft SQL customer, then there is this open source project supported by Apache Kafka Foundation Debezium, which is doing the work pretty well. They have like early version of Oracle as well. If you are Oracle customer that perhaps you're already using Golden Gate for disaster recovery or for other scenarios, Kafka is also working with the Golden Gate pretty well. So you get all the changes happening in the Siebel database seamlessly through the CDC connection, and then through Kafka, you push it wherever you want to push it. And to read data into Siebel, so we would build a sync connector, which would effectively call Siebel REST API and push the data into Siebel. Another thing which I maybe tried to demonstrate a little bit, I think many customers want to have Google-like search experience within Siebel instead of querying Siebel data through Control-Q, Control-R commands. As we built these Nexus applications, which we were showing on Wednesday, we kind of usually try to build also this global search capability. Basically, that if I search for Idea Portriga as a company, I see some of the objects, maybe these are tasks, which have this particular search term, and I kind of filter them. And if I look for accounts which have the same search term, I, for example, see Idea Portriga here. So if I click on it, I go to particular account. So if I could have this global search across different record types or business components within Siebel, it would be, very awesome. Almost like Salesforce. Oracle is working on that. Unfortunately, I don't know how far they're getting because it's kind of hard to dig out this information. But the idea is that we could stream the data with a very low latency through Kafka to Elasticsearch. And then in the UI, have this pattern that for the search, we use this REST API, which works on top of Elastic. And then whenever we identified the record that we need to, we know its type and we know its row ID. And then we access Siebel data through the presentation model via Nexus Bridge, the way how we do it in Nexus Face. The challenge that we are working on now, and maybe next January, there will be Oleg looking into this problem, is how we can enforce same data access control for the users. So, because again, in Siebel, we have usually pretty strict visibility rules. And if we replicate entire Siebel database, we cannot just give it to any user. So we need to ensure that there is proper access control in place as well. And basically how to replicate this visibility automatically or manually into some kind of additional layer on top of Elasticsearch, which would extend the queries which we are running based on the user who is calling them. This is the problem we need to tackle. And if you have some good ideas, we are kind of really eager to hear if you have solved it or have an idea how to solve it. Another topic here is that we also see that at many companies, Kafka is starting to take a place of sort of traditional middleware platform, because Kafka is not just supporting publish, subscribe pattern, but many others. Another point that Kafka is trying to make that currently in the enterprise, you would have message queue, people process engine, maybe complex events processing if company that's sophisticated. Maybe you would also have some ETL tools for your data warehousing and stuff. So basically, you have quite a big toolbox of tools to data transformation, data analysis between different systems. And the challenge Kafka issues is that, hey guys, we have all these basic components in place already. So we have messaging for you. You can store it infinitely. We have connectors built to pretty much every system or database on Earth. And we can do all this fancy stream processing that we're going to show you in a moment. And why do you need to have these several vendors and stuff instead of having Kafka from Confluent? from technical characteristics, once again, Kafka scales really well. It has very good throughput as well. And as we kind of decouple the client, we're able to solve some of the pressure problem or unavailable consumer problems. At this moment, I was going to do some of the war stories from my previous day, but we'll skip it for today. And here's like a good post from one guy working at Confluent, from Kai, and he kind of explains, where Kafka and the middleware are friends, where are they enemies, where are they frenemies, and how basically to find the best combination at your enterprise. Okay, another aspect which we kind of covered during the overview webinar is that gradually in the Siebel world, we start to talk about microservices, okay? So some people at Oracle want to look at Siebel as a microservices, saying, hey, we have all these different components, which technically are different services doing their own things autonomously from the others. And of course, 25 years ago, microservices were not present. But if this pattern would exist back then, Siebel would be sort of microservice application. For many customers, it's kind of hard to adopt view of Siebel as a microservice. But then why it was relatively easy to Siebel to become cloud native application is exactly to this great componentization of Siebel object managers and components that we run on the Siebel servers. Then, with the CQRS, we also talk about decoupling of the system, which is also coming from the microservices pattern world as a concept. And another concept in this microservice domain is that let's have dump pipes and smart endpoints. Kind of the way how we can interpret it in the Kafka world, that typically if we would have Siebel system and some other system like SAP, and we need to connect the system together, there would be an enterprise service bus team who would tell us, okay, guys, in this format or whatever format you want to send us the data at these certain time periods, and we're a bit in the control of it. Then we will do everything we need to do as integration guys, all the data transformation, changing different adapters, REST to SOAP or whatever. We can also do some orchestration in a fancy way, call different system and sequence, get the data, and then call another system. So this is like all of the smartness in the integration goes into the ESB, okay? And effectively, if you are sitting on another end of the pipe, also it's middleware team who is going to feed you the data when they feel like it in the format which they kind of agreed with you, but they pretty much control everything. And whenever changes is happening, like, we need to extend the contract between different systems, you always need to talk to the middleware team. And sometimes maybe this is fine from the enterprise architecture point of view, but when you kind of go to field level projects, usually projects are getting pissed off because these guys in the middle sometimes create extra obstacles in terms of agility of the implementation of the changes. Especially now, it's kind of work in the agile environment. They have the sprints and with the plans done for 3 months in ahead. And sometimes in this kind of approach, it's hard to get the changes done in the integration as fast as you need. Okay, and the Kafka way or kind of microservice way is that let's keep the pipe in the middle like really dumb. There is no logic to that. It reliably gets messages, stores them, and whatever consumers are subscribed to this topic, they can get the data whenever they want it at their own pace. And we as a Kafka keep the track how far did you get in processing of the messages. So this is like another feature of Kafka. And with that setup, basically, it would be System 1 development team, which would be responsible for the source connector, for pushing data out of the source system, or if they are pure event producer, just putting into the Kafka topic. Of course, you would need to have like centralized operational team, which would need to run Kafka for you, for example, in the Kubernetes cluster, and also would sort of manage what kind of topics are there and then create them or delete them. And then whoever needs to consume the data, they would build their own sync connector, and they would do their own transformation of this data that fits their requirements and consume it on the pace that they need. And this is maybe subtle different, but I think it's kind of significant one, because as we decouple the system, we also decouple the teams. And in the decouple format, we can move ahead much faster without dependency on the middle guy. Next topic here, what we wanted to do, we wanted to show you one of the demos, which we've done for the customer who is considering to implement Salesforce, and they were looking to use some MuleSoft as a middleware platform. And basically with this customer, we just showed him how bi-directional interface between Salesforce and another system could be done. And this is what we're gonna show you right away. Dmitry, could you please start sharing then your screen and take over for now?
In this demo, we connected Salesforce to our Salesforce that's on the left side, and on the right side we have a custom built small web application that displays data from its own internal storage. which is backed up by Cosmos DB. What we have done is that we have implemented two connectors to Kafka. One is reading data from Salesforce streaming API. Salesforce natively exposes the concept of platform events that we have utilized. Also, we have implemented a second component that basically monitors this Kafka topic, where the first connector has put it in data, pulls this data to the UI. From the demonstration point of view, after the change has been done to the Salesforce, the event has been picked up by connector. It was put into Salesforce topic. So this up from the restart. And here we should have this event on account 03 update. This communicates this update, and this update has been reflected here as well. From the observability point of view, from the Kubernetes point of view, these metrics produced by these connectors can easily be consumed by Kubernetes observability tools, and in this case, displayed, for example, these Grafana dashboards. So we have this activity on our changes. Also, we have implemented integration for another flow. So we are doing update over here in the contacts. So we should see the change here. On the refresh, yes, we see the update to the contact. As you can also see that update has looked back to the UI of this application. That's because Salesforce was destined to be a master data in our scenario, a master source system. And so any update that has been pushed to Salesforce gets automatically republished to the topic, where it can be immediately consumed by any amount of other consumers, not just this application.
Here, I mean, also you could see that this, very low latency, which is happening, when this integration works. So especially from Salesforce to this web application, because this web application, do you use webhook? How do we prevent infinite loopbacks? Ask Jason. Maybe Dmitry, you can answer the question in the question and answer. But still, I think that this sending messages back and forth is nothing fancy. I mean, we've been doing it for like entire life. And this is pretty much the way how we look at the integration patterns. At least to me, this stream processing is something very different, because I myself deeply rooted in this domain-driven design when we think about the objects which have the latest state and then how we join them together and stuff like that. But effectively, you can also think about IT as a sequence of events that, somebody updated one customer record, another customer record, and how it all plays together and what actions we should take based on these events. And this is somewhat different perspective. And, again, for me, it just takes time to digest it. Maybe for Alex Hanzal, it's easier as he's a very analytical person. For me, it's a bit difficult. So the stuff here is that, okay, we've got these producers and consumers or source system, target system. We've got Kafka topics. And the first thing we have is that we have the different Kafka components or technologies, whatever you want to call them, which provides you with the stream processing. And on one hand, you can use the stuff which comes from Kafka, like Stream API and KSQL DB, but also you can use Spark, which is also fit for these purposes. The point is first that the data we have in Kafka, this stream of messages which are going through, could be represented internally in the stream processors as a stream, a sequence of events. So they have like one way to explain it that, for example, if you play chess, you can keep the record as moves. One player moved his chess from one place to another and recorded, and another one did so. And basically, you can keep the log of the different moves both players made. And this is like stream representation of that. Also, you can look at the data, which is in Kafka topics as a table. Like, again, using this chess analogy, we see a certain combination of figures on the table. And this is like how it is now, okay? So, and this is what we also can define with these two technologies, which is Kafka SQL database, and we can start working with that. The things you can do with it, it's a lot, but they are still limited. To do that, you can use the SQL-like queries. And for people working with Siebel, we are good at SQL. Streaming API is a library which you can incorporate in your Java or Scala application, and then it effectively does also a lot of things and even more than KSQL DB. the things you can do with that is goes in this capability section. So you can do transformation of the messages. So you can maybe mask some of the data or read what's going on there and apply some logic to that. You can be filtering events as well. Let's say there is huge chunk of events going through one topic. You want to filter it and move them to another topic, which is possible. You can do aggregation of the data. So you kind of calculate the average number, count of events which are going through some other metrics as well, put them together. You can be joining topics as well, so that, for example, in the classical example, they have that, for example, you have topic with data about the vehicle drivers and the vehicle driving. And whenever people are getting to work or whenever vehicles start to drive, these two topics are used for streaming appropriate events. And then with this Kafka stream processor capability, you are able to join the topics. So you can do analysis on both topics at the same time. And then since they are presented as a stream or tables, you can also mix and match them the way you want to. Another cool feature, what they have is this time windowing, so that you can do the analysis of a particular time period. And this is what we're going to show you in these demos. We utilized the same approach from the previous demonstration, like Salesforce and our custom web application with the Cosmos DB behind it. And what we've done is that, let's say, if we believe that some kind of crazy Salesforce user is updating the user data too much, then this is like really suspicious activities. And by too much, we define more than 5 updates per minute. And when this happens, we will generate event for another topic. And then there will be a consuming application, which is picking up this event and is doing something. So in our scenario, in this web application we were showing to you, there will be sort of alert going on. And Dmitry, with that, maybe you can take over again and show us how it's done. So this is what Roman Zhuk's developed within a couple of days.
The use case that we're basically expecting is that when multiple changes are done to one of the accounts, notification is displayed on this part as well in the application. So let's basically try to make multiple updates as fast as possible. Simulating some unusual behavior. Already fired. What can be observed here? The notification has been displayed. Basically, we are back in this topic. There were quite a few events. We can see from the timestamp that there were a few of them in quite a short time notice. We have a separate topic for alerts, where after judging by the timestamp where it's already triggered, and the event to this topic has been published by a separate streaming API component that's been monitoring the input topic for incoming events and maintaining the state over some period of time.
All right. But it was, again, very simple stuff, so that we're not just moving the data from one system to another or whatever, generating events, which, again, in these scenarios, this web application was interested in consuming, but also we can apply some cool stuff on top of it. Okay, let's move on. The use cases for that, they are pretty much related to how you can take the action in the real time. So it is not that we run some kind of a report and say, hey, somebody was updating this customer data too often, let's investigate it. So we can do the action about some suspicious activity, about some risk we have detected, or again, opportunity we have detected in the real time when everything is still going on. Another kind of a risk which we have figured out because of the certain pattern, how events are going on, or again, some opportunity that maybe this is the right moment for us to do something and something wonderful happens to our customer. Another kind of common scenario is to do the predictions and the recommendation on the fly, so that maybe you've seen some of the examples when people are talking on the phone and behind the scene, something happening, like what user is talking about, what they are complaining or what they are discussing. And on the back of the system, there is something which is listening to these events, applying maybe some machine learning to that, and then at the end recommend the operator or whoever is servicing this customer offer something or propose an offer to retain the customer if they're about to leave. And of course, another thing is that you can do different analytics on top of it. So like how many events of this type were going on through the system, or how many revenues we have generated because of the sales orders are going on. So basically, kind of my point here is that in addition to all integration stuff, publish and subscribe, which we kind of used to in the real world, for us, it can open up totally different domain on how we can work with the data, which is transitioning from one system to another. So if you kind of start adopting this event-driven mindset a little bit, I'm sure we can discover very interesting cases also around Siebel. And here's another link with the Kafka tutorials. This is the site which Roman's used for a couple of days, and then he was able to build the streaming API prototype for this demo. But because like all the other guys with the Kafka knowledge are pretty busy right now. All right, next, this is a slide from Confluent, and it explains how Kafka can be gradually adopted in the enterprise companies. First, there are some early interest and some experiments on the project level. And then, it can start crossing kind of line of business lines or whatever barriers. And then it could kind of gradually become a platform within the enterprise. And again, we have the one bank we work with, which is using Kafka on the massive scale, and they are kind of pretty much on this level 5 already. As for the next step, because we're kind of already out of time here, recommend you to watch these webinars from Siebel Virtual Summit. This 10 minutes on Kafka, if you kind of really look at Kafka only. Then figured out if your organization already is running Kafka. So maybe you are one of these companies which kind of adopted Kafka as a platform, but Siebel was kind of staying there somewhere behind, not being involved. Then ideate and come up with your use case for Kafka. Again, something simple with user action audit to improving performance by implementing command query responsibility segregation pattern and moving the data from Siebel so that these digital applications don't talk and bother us, or get it from the other sources into Siebel so that when we need to serve the data to our users, we don't need to wait on these backend guys, which sometimes are slow and inefficient. Run and deploy Kafka in Kubernetes cluster. When you will be on the cloud native, you will already have it. In Siebel Kubernetes clusters, there will be Kafka running so that you can take a use of it. But then setting it up in Kubernetes cluster, kind of, it's not also a big deal. And there are some tools to help you to do that, because at this stage, Kafka is not cloud native application itself, and Confluent is working on it. And if you need to start doing that, we can also kind of share some initial experience and get you started with that. And then eventually, when Siebel releases Event Driven Framework, it's going to be much easier for Siebel to talk to Kafka in both ways, to listen and publish messages. And then I think with the cloud native architecture, when we deploy it, Kafka will be a daily part of how we look at Siebel, how Siebel is working for us, and it will be kind of new reality for all the Siebel folks. And again, something exciting to learn as well. Okay, with that, I stop presenting, and thank you guys for joining. Enjoy the Christmas season as much as we can, and then let's celebrate New Year. And I hope it's going to get better in the spring or the summer with all this COVID, and we can go and have live meetings with all of you. Thank you very much. And with that, we finish this session.